What if everything the West believed about off-road dominance was already obsolete? For 50 years, the formula never changed. A steel frame, a thundering V8, mechanical axles, locking differentials, and a six-figure price tag to go with it. It was loud, heavy, and completely predictable. And legacy brands from Detroit to Stuttgart sold it to the world as the pinnacle of rugged engineering. Then China showed up. Not with an imitation, not with a cheaper copy, with something the traditional off-road industry genuinely did not see coming. This is the Jetour Traveler 8, and this is where 50 years of Western off-road supremacy starts to crack. To understand what makes the Traveler 8 genuinely dangerous to the established order, you need to understand the blueprint it is replacing. The traditional hardcore off-roader has always been built around one core philosophy: mechanical brute force. You take a heavy ladder frame chassis, hang solid axles front and rear, and run power through a transfer case and locking differentials that physically force both wheels on the same axle to spin together. Simple, proven, extremely difficult to break in the field. And when Western automakers began electrifying this formula, they largely kept the same thinking. The General Motors Hummer EV arrived weighing nearly 9,000 pounds, with a 200 kilowatt-hour battery pack and 3 motors still routed through conventional axle hardware. Impressive numbers on paper. But the architecture underneath? Still the same heavy truck philosophy, just with batteries instead of a V8. Rivian went further with genuine quad-motor capability on the R1T. But even their system roots power through reduction gearboxes and half shafts. Physical hardware connecting motor to wheel, carrying the weight and complexity penalties that come with it. Meanwhile, Jetour, the heavy-duty off-road division of Chery Automobile, was asking a completely different question. Not how do we electrify the existing formula, but rather, what if we deleted the formula entirely? The result is the Kun platform, a digital mechanical chassis architecture built from a blank sheet of paper with zero inherited assumptions from the traditional off-road world, and the Traveler 8 is its most extreme expression. The physics ceiling nobody talks about. Here is the uncomfortable truth about mechanical four-wheel drive systems. The same properties that make them reliable in the field also impose a hard ceiling on how precisely they can manage traction. In a traditional 4x4, when a tire slips, the mechanical system detects that slip through changes in rotational resistance. And even with modern electronic traction control layered on top, the response loop from slip detection to torque redirection takes somewhere between 50 and 100 milliseconds. On a boulder field where every wheel faces a different surface, that delay costs you momentum. Sometimes it costs you the trail entirely. Locking differentials solve one problem and create another. Lock the front axle for maximum traction, and you immediately compromise steering precision. You are always trading one capability for another, and the mechanical system cannot deliver both simultaneously. Physics will not allow it. The Western EV response added a third problem: range. Take a Hummer EV deep into genuine wilderness, drain the battery fighting through mud and rocks, and you are not looking at a 20-minute fast charge. You are looking at a level 2 outlet at a remote campsite delivering 11 kilowatts against a 200 kilowatt-hour pack. That is an 18-hour wait, not a range anxiety problem, a survival logistics problem. This is the gap Jetour decided to engineer around completely. 4 motors, 0 axles, 1 AI brain. The Kun platform eliminates the mechanical drivetrain at its root. No transfer case, no locking differentials, no half shafts connecting left wheel to right wheel. Instead, four independent 250-kilowatt electric motors mount directly at each wheel corner, with zero mechanical relationship to each other. Combined output, 1,282 horsepower. 0 to 60 miles per hour in 3.0 seconds flat from a vehicle designed to crawl over boulders. For reference, the most powerful production Land Rover Defender ever built produces 518 horsepower. The Traveller 8 generates more than twice that from a simpler mechanical architecture. But the horsepower figure is almost a distraction from the real engineering story. Because each motor is independent, a single AI controller can assign a different torque target to each wheel, recalculated hundreds of times per second. The system reads wheel speed sensors, inertial measurement units, terrain cameras, and steering angle data simultaneously. If the front left tire finds solid rock while the other three are spinning in deep mud, the AI delivers full torque to that one wheel in milliseconds, without the driver touching a lever or a button. Traditional traction control works by cutting power to slipping wheels. The Kun system does the opposite. It maximizes power to wheels with grip. The philosophical difference produces dramatically different results on extreme terrain. Steering that defies geometry. Combine four independent motors with a rear-wheel steering system that articulates at plus or minus 10 degrees, and something remarkable becomes possible. The left side motors can spin forward while the right side motors spin backward, simultaneously. With the rear wheels turned to full articulation, the vehicle performs a perfect 360-degree pivot on its own axis. Zero forward movement, zero rearward movement, pure rotation. General Motors marketed the Hummer EV's crabwalk feature heavily, a party trick that allowed diagonal movement at low speeds. Jator's engineers looked at that and built a vehicle that doesn't just walk sideways. It spins like a compass needle on a mountain trail. Practical implication: trapped on a narrow dead-end dirt road with a cliff on one side and a rock wall on the other. A traditional off-roader is genuinely stuck. The Traveller 8 rotates in place and drives back the way it came. The EREV. Solution: engineering around the wilderness. Problem: this is where Jator plays its most strategically important card. The Traveller 8 is not a pure battery electric vehicle. It is an extended-range electric vehicle, an EREV. And the distinction is critical. Embedded within the platform is an internal combustion engine that has zero mechanical connection to the wheels. It never drives the vehicle. Its sole purpose is to run at a fixed thermally optimal RPM, the single most efficient operating point of the combustion cycle, and generate electricity on demand, feeding it directly into the battery pack and through to the four motors. Because the engine never has to respond to variable wheel load demands, it never has to rev up or down chasing driver inputs. It simply burns fuel at peak thermal efficiency and produces electricity. The motors handle everything else. The result: a combined operating range of 870 miles, 1,400 kilometers, completely independent of charging infrastructure. And when the battery depletes on a remote trail, the engine activates, refills the pack, and the journey continues. At camp, the vehicle-to-load system powers lighting, cooking equipment, and heating for extended periods without the engine running at all. The psychological and practical gap between this and a pure battery EV in a genuine wilderness context is total. It is not an incremental improvement, it is a different category of vehicle. Put the Traveller 8 next to the vehicles that currently define premium off-road capability, and the contrast is hard to look away from. The Mercedes G-Wagon, AMG G63, perhaps the most iconic off-road status symbol ever built, delivers 577 horsepower through a 9-speed automatic and mechanical locking differentials. Superb engineering, also fundamentally the same architecture Mercedes has been refining since 1979. The Hummer EV carries 830 horsepower and a genuinely impressive 800-volt electrical system, wrapped inside a platform approaching 4,500 kilograms of curb weight and a real-world off-road range that fades well below 200 miles in demanding conditions. The gap this reveals is not just technical. It is philosophical. The Western automakers have been iterating within established boundaries, more power, larger batteries, faster charging, while the underlying architecture remained anchored to decades of legacy assumptions. Jetour built without those anchors. No inherited tooling investments, no legacy platform to protect, no brand mythology telling their engineers what an off-roader is supposed to look and sound like. Just a blank page and a question. What does maximum capability actually require? The answer eliminated the axle, the differential, the drivetrain hardware, the range limitation, and the compromise between electric performance and wilderness survival. There is a specific kind of disruption that does not arrive loudly. It arrives by making everything that came before it look quietly, irreversibly insufficient. The Jetour Traveller 8 does not just outperform the G-Wagon or the Hummer E5 on a specification sheet. It operates on different engineering principles altogether, principles the traditional industry spent 50 years dismissing as either impossible or unnecessary. The benchmark for what an off-road vehicle can be has moved, and it has moved to a place where mechanical axles, locking differentials, and combustion-only powertrains are no longer the answer. They are the limitation. Western automakers now face a question that marketing budgets and heritage stories cannot answer. Can they move fast enough, think differently enough, and let go of enough legacy pride to respond before the market makes the decision for them? Because heritage does not climb a mountain, engineering does.